and welcome to Lancaster County Timber Frames. You're here at our plant in eastern York County, which may beg the question, why do we call ourselves Lancaster County Timber Frames? We founded the company in Lancaster. The co-founder and I both live in Lancaster County, and we practiced the crafts there for about a decade before moving operations to York County, where the commercial real estate is priced a little bit more reasonably than it is across the Susquehanna River. I'm Tony Zaya, president of Lancaster County Timber Frames, and the oldest person here. Those two facts may have more than a casual connection. Today you'll be seeing the practices of a craft that is ancient, a craft that dates back 7,000 years. Timber framing is the art, the science of creating structure by connecting large, heavy timbers by means of different types of joinery. The most basic of these joints is the mortise and tenon, of which there are hundreds of variations. This little mock-up demonstrates those basic joints. You have a rafter sitting on a lower chord with a queen post. They're connected by tenons, which are positive space, going into mortises, which are negative space, and locked in position by use of wooden pegs. Chuck will be pulling it apart to show you the internal workings. That is the heart of timber framing. Everything we do is a variation of this. And the type of joint, the size of the wood is all dependent upon the structure. And we'll take you upstairs and show you where the process begins. And then we'll follow up with the practices in the shop. This is our meeting room. In the mornings, we get together and decide what has changed overnight, what the process is going to be through the day. On that board, you see samples of projects that we're currently working on. They may be in the design phase, they may be in the engineering phase, they may be in the fabrication stage. But having a visual reference makes it easy for everyone in the room to follow what we're discussing. I think you'll see that there's a wide range of type of projects and sizes that we get involved in. Some are very modest, some are very elaborate. One of the big problems in any type of construction is scheduling, particularly when your backlog goes 6 months into the future. Years ago, we used to have a dry erase scheduling board. So many changes were occurring that we decided to go magnetic. Each color designates a different project into the future. And as anyone in construction knows, the GC or general contractor is pretty much acting as a orchestra conductor. If there's a delay because of concrete not being poured on time, if there's a problem with one of the other subcontractors, we get a call, they want to delay their project, which affects every project after their project. So it's always a balancing act, trying to fill in or flesh out a particular time period. This is our design area. We have 4 full-time designers. Usually with our designers, they also participate in the raising of the project. They are often in the shop or out at the job site, but the bulk of their time is spent at a computer doing design work. We get involved in the design at various points in the development. Sometimes in the very beginning we coordinate with an architect. Sometimes we do the complete architecturals. Sometimes we get involved after the architecturals are completely done. works much better if we get involved in the beginning. On Tim's computer screen, you're seeing some projects that we've done in the past. This was a project in Conestoga, Maryland, attaching a new room to an old farmhouse. This was a project close to home in our backyard in York, Pennsylvania, overlooking the Susquehanna River. Front entrance to that house. This is the inside shot of the great room of that house. Another project in our backyard. This is in Mount Joy, Pennsylvania. It was a very elaborate project, very large project for us. It's a residence, very large family. Very simple design, erected near Allentown, Pennsylvania. Whitewashed ceiling boards, Doug fir timbers. This is a fairly contemporary looking project. This was done in Philadelphia, in the suburbs of Philadelphia. Exterior looked very, very contemporary with this addition. Interior shot of the same project. It was a kitchen, dining room area that was added onto pretty much a development house. This is a project just outside of Washington, D.C. The timbers on this project were recycled Doug fir. They were taken from the original Marconi factory in Montreal, Quebec, when that factory was dismantled. Another shot of that same project. Again, the kitchen of that project. And an unfurnished living room in that particular residence. This is a farmhouse that we designed for the oldest cattle ranch in the country. It was in continuous operation since 1658. Surprisingly, it's on Long Island, and it is at the very tip, Montauk, Long Island. The timbers are all recycled. The client wanted the look and feel of an old ranch or farmhouse. This is a project from Westchester, Pennsylvania. An old farmhouse and an old barn were connected by a timber frame structure. The walkway from the original farmhouse to the barn through the room we did is solid mahogany. It was 5 feet wide, 8 to 9 inches thick, and originally was 26 feet long. The owner had it in storage for decades. It was originally from pre-Castro, Cuba. Beautiful piece of wood. This is a pool house from the Pocono areas of Pennsylvania. This was the second project we did for the clients. Maybe 2 or 3 years previous to this, we had done a whole house timber frame for them. One of the interesting things about timber framing, even though it's ancient, it's a method, it's not a style. You can get whatever look, whatever feel, whatever mood you want. This is a rather contemporary looking structure from Lancaster County, Pennsylvania. The use of metal gave it sort of an industrial look. This is a photograph of a house we raised in Reading, Pennsylvania. Years ago, this would have been done by hand. You can see a crane cable coming down. The crane makes the job a lot safer than hand raisings were. This is a gambrel style roof system we did for a residence in Long Island. Another Long Island project that has a very, very contemporary feel. And I had mentioned previously that some of our projects are very large. Some of them are very small. This is a barbecue pit structure that enhanced the patio area for this client. This was a real gem to work on. This was a chapel in North Carolina at Belmont Abbey College. The challenge in this project was that the walls, where there wasn't timber, there was glass. No other structure involved, and glass is very rigid. And the conditions in that particular area of the state were such that we had to go to fairly extraordinary means to make sure the whole structure was extremely rigid. An inside shot. The architect had wanted to give the feeling that the people in the chapel were in the forest. And from this particular view, from this particular photograph, I think he achieved what he was going after. After the drawings are completed, we usually, even though we have an engineer on staff, send them out for third-party engineering. At that point, the timbers have already been ordered and probably delivered. We get the timbers sized according to the job. We don't keep a huge store of timbers of various sizes. They're job specific, and we can get them in an S4S finish, which means they've been surfaced on all four sides. We can get them in a bandsaw cut or a rough cut fashion. This particular project, the species is Doug fir and was delivered S4S. When the drawings are brought down and the project laid out, it is laid out by someone other than the person who designed it. The layout people take the working drawings, transfer all the numerical information from the drawing to the timbers. They have specific marks and designations that the craftsmen who are cutting it are able to interpret. In fact, the people who lay out the drawings, the people who check the drawings may be this very same people who are carving on the drawings after the designer comes down, rechecks everything, and signs off on each individual piece. A typical frame can have 200 timbers and 400 to 500 joints. Mistakes are very costly. A small timber can cost $100. A very massive timber can cost in excess of $1,000. A large timber can necessitate a full day of carving. If a mistake is made at the very end, the cost can be $1,500. In some cases, it's been as high as $2,000. To eliminate the possibility of mistakes, we have the designer who designed it come down, check every joint, every measurement before the craftsmen start cutting on it. This is a project that is going to the central part of New Jersey. It's a pool house. Pictorial view, top view. There's also details of each timber that goes into the making of this project. The men, as they're laying it out, color in each particular timber so we don't cut the same piece twice. Tim Diener is the designer who designed this particular project, and he's the person doing the checking on it. If there is a mistake, he shares the weight with the layout person. But because of the double checking, mistakes are kept to a minimum. Compared to what was happening to us 20-some years ago, we often do a whole project without a mistake. In the early years, when we didn't have computers to do the three-dimensional drawings and the working drawings, we made models of everything we built. On the wall is a model of Plain and Fancy in Birdenham, Pennsylvania. It was one of our early projects. They were an awful lot of fun to build, but they were very time-consuming. Most of the models we made in the past were made to the same scale as dollhouses, so clients usually took the model for their children or grandchildren. This project is a little bit of a departure for us. We usually don't get involved with a lot of external metal plates, but the look of it was something that intrigued us. This is a roof system for a locker room at the Chevy Chase golf course near Washington. It is yellow pine. It is unfinished at this point. The metal will be painted and the wood will be stained. We're waiting for word on delivery before final touches are put on this particular project. Brian's getting ready to carve a mortise. A mortise is the negative space in the timber. What he is doing here, what he just did, was he scored the material counter to the grain so that when he uses the chain mortiser, it doesn't lift up any of the wood. Years ago, 15 years ago, we didn't have chain mortisers. We had to drill these out by hand, and it was very laborious, very time-consuming. This is a German tool. It makes very short work of the mortise. Most of our mortises are 2 inches wide, so Brian will be resetting the tool and doing the other portion of it. This does not eliminate the need for chisel work. These are finished up with a chisel, and you can see how the scoring prevented that wood from lifting up at the very edge where it will be visible. Chisel work will never be a small part of what we do. It's a large part of what we do. Each joint, male or female, has to be clean. It has to be absolutely plumb to the surface. Timber frame chisels are usually 2 inches wide or 1.5 inches wide. They were designed that way eons ago. We've kept the same sizes. They work out for engineering. He's also relieving the edge here so that the tenon going in has a draft, a slight draft to work with. It helps position the tenon going into the mortise. Often with our timber frames, we have different size pieces going into larger pieces, smaller pieces into larger. Rather than just have a tenon at the very end, we take the piece that's intersecting and we set it in 1 inch before the tenon starts, so that if humidity swings cause a piece to expand or contract, you don't have daylight showing through the joint. To do that, we make jigs up to route out to a depth of 1 inch. And that's what Josh will be demonstrating right now. He's setting the depth. He's not trying to take it all out at once. That'd be too difficult, too disruptive to the timber. Now he's at the final depth. And what he'll do next is take off the bar clamps, remove the jig, and you'll notice that the corners of the housing, that 1 inch depth area, are rounded because of the nature of the router. Those will be squared up by chisel. You also see a series of lines. Those will be chiseled down to the exact size needed when we're putting the opposing part in during the prefit. He'll clean it out now, square the corners, clean it up, and then that particular joint will be initialed by him. It's something each of the craftsmen do when they're finished a joint. They put their initials on it. During pre-fit, if there's an issue, we know who carved that joint, but the men are pretty much self-policing. The people who are pre-fitting it in the shop let their dissatisfaction with anything be known clearly and loudly. Most of the sawing is done with circular saws, although we do use other types. The thing the men do that is essential is they distrust the base of a saw. Every time they use a saw to cut a particular new joint, they check the angle. Sometimes, or most times, that angle is 90 degrees, but in other cases, we have to set at various angles. Brian's in the process of checking the angle from the blade to the base. He doesn't trust any indicator that comes already implanted on the saw. If a saw is dropped once, that base is going to be totally not dependable. The cut Brian is making is for the bird's mouth of a rafter that will be coming into this lower chord of a roof system. Right now he's checking the depth against pre-laid out lines on that timber. A little bit earlier, I mentioned that we penetrate the timber by a depth of 1 inch for intersecting pieces. This solid line shows the end of that 1 inch mark. This dashed line shows the surface where the other timber will come to. Ken's going to be showing us the cutting off process. He's using a 16-inch saw. If we were using anything smaller, he'd have to roll the timber, and in very large pieces, he'd have to take a handsaw to finish up. But because of the depth of this saw, he can make that that cut in one pass. What we'll be showing you now is the joinery at the top of a rafter going into a king post. This is the finished joint. It shows a reduction so that this 8-inch piece going into another 8-inch piece is inside it. It is away from the edge of it. We do that by a gradual taper. Josh will be demonstrating the process of going from that to this. Now, I'm not sure the camera picked it up, but Josh placed his chisel on the floor, leading edge up. We've learned from experience that a drop chisel is a bad chisel. It can take up to an hour and a half to put a new edge on it. This is a bird's mouth joint that Josh is finishing up. There are two critical areas, two critical size spots. This line, that line, and the opposing line on the bottom. Those have to hit the timber they sit on first. So he will be drafting this just ever so slightly so that it'll fit extremely tightly when it mates with the cord that it's going into. It's a fairly labor-intensive process. When he's finished, we'd be able to put a straight edge from this edge to this edge. We should be able to see a little bit of daylight at the center of the belly. Thank you, Josh. As I mentioned previously, the average frame can have 100, 150 timbers, some much more in excess of that. And usually the joinery can number 400 or 500 joints. We want to make sure before we ship it to the job site and then show up to erect it that everything is going to go together correctly. So we build the structures two-dimensionally on the floor, put it together, then pre-bore it for the pegs that will lock the mortise and tenon joints together. Luke and Mitch are in the process of putting together one of the bent sections or truss systems, trusses for the pool house in northern Jersey. The pieces of cardboard are put on the edges of the timber to protect the timber before pressure is put on it by use of a come-along. I'll hold that in place, Mitch. Just a minute. Okay. The upper part of the truss system has already been pre-fit. The come-alongs holding it in place. They have one more section to put together on that end. Each of the timbers are numbered, lettered, so we know where everything goes. And when we take it apart, we won't confuse it, put it in the wrong place. Now everything is ready to be pre-bored. The use of a stand with a drill helps keep that bit perfectly perpendicular to the timber it's drilling through. All the peg holes are marked off during layout. After this process, after all the peg holes have been bored, the timbers will be taken apart. Any curves that have to be put on any of the brace pieces, any stop chamfers that are put on the edge of the timbers will take place at that time. Then the timbers will be sanded, finished, then wrapped for shipping. Each craftsman has their own cart, and each of them have their own particular way of outfitting the cart. Each of them probably has at least a half a dozen chisels for different operations, different procedures. Here we have some very small bench chisels, and the larger framing chisels are stored down below in leather. All the layout tools he needs, all the marking devices, mallets, plane irons, framing squares, tape measures, all have their particular place in each cart. This gentleman chose a different way of doing it, but probably just as effective. These chisels are custom made by hand by a blacksmith who learned his craft over a period of 10 years in Japan. We've been using his chisels for 22 years. Prior to that, we used what was conventionally on the market, and we spent an awful lot of time honing, sharpening, putting new edges on. The hand forming methods he uses of introducing carbon into the steel yield a project or a chisel much better than you could get with mass production. Our sharpening time has diminished by at least 90%. There's a premium in cost, but that premium in cost is more than balanced by the reduced sharpening time. We produce between 30 and 35 projects a year. Again, some small, some large. But for a company that produces that many projects, we're a little bit of an anomaly, a little bit of a rarity. Most companies with that type of production use a CNC machine. We do everything by hand. We have no philosophical problems with the machine. I believe CNC machines are fantastic, but I restrict that advantage to homogenized materials such as plastic and various metals. For an organic material like wood, I don't think that anything can match the hand and eye of a good craftsman. And because our people have developed into very good craftsmen over the years, they're very particular about the edge that is put on their chisel. We do not send the chisels out to a sharpening service. We do all of our own sharpening in-house, and only one person does the sharpening. Chuck will be demonstrating rather quickly the process. Believe me, in real time, it takes a lot longer to put the proper edge on a chisel. We are using a water wheel which keeps the heat very, very low and doesn't disrupt the temper of the steel. This is a very, very fine grit wheel that Chuck's using. If a chisel were to drop, we'd have to put a much coarser wheel on there to correct the imperfection. The most important part of sharpening a chisel is to make sure the back end of it, the back side of it, is perfectly flat. If Chuck finds that it isn't, after he puts it over a diamond stone, he will work on it until it is flat. If you don't have a flat back, no matter what type of edge you put on the cutting surface, the cutting edge, it won't matter. The chisel will not perform. Chuck is putting a magic marker line on the leading edge, which will help him gauge if he has the wheel to the edge set perfectly. Basically, all sharpening is removing larger scratches with smaller scratches. The finer the wheel, the finer the scratch. You want to get the finished tool microscopically as close to dead smooth as possible. If the chisels are maintained constantly, this becomes easier and easier. Chuck is removing the burr from the back of the chisel. At this point, he's going to polish the cutting edge with compound on a leather wheel. When he's finished, it should have a mirror surface. And it should be sharp enough to shave with. Years ago, we used to test these. Instead of using paper, we'd shave the hair off our forearms. But after a while, we started looking like sissies. Thank you, Chuck. This is our sanding area and storage area. We do the finishing outside, but sanding is done during the colder weather inside. Before the sanding begins, stop chamfers are put on most of the timber edges. And to allow the men to stop at the proper position, there's red tick marks at different intersecting points where other timbers are coming in. Here's another example. They know that the base of the router has to stop there and can start here. If they took the router straight through here, it would look terrible because the intersecting piece is sitting right on top of that. And it looks like junior high work if the chamfer goes all the way through. Andy's going to be demonstrating routing. It's time to sand. Wes and JC have that particular job today. They'll be erasing any imperfections, any red marks, any layout marks. After they're finished, the timbers are stacked until the whole project's done, then everything is finished outside. The typical finish at our client's request is a clear oil finish, but we have done some whitewashing. We tried to stay away from staining. Throughout history, starting with the Egyptians and the Greeks, wood has been copied, it has been imitated. The Greeks used stone to imitate wood, then plaster. Then with the Romans, they did it with concrete. And in recent years, we've done it with aluminum and steel and plastic. We've tried to capture the soul and essence of wood in these other materials, and it's been largely unsuccessful. Because wood is not only a visual engagement, it screams to be touched. It exudes warmth. These factors are the attraction that keep us busy even during these difficult economic times. Wood also is a very green product. Of all the structural building materials in the world, on this planet, only wood is renewable. Only wood supplies us with oxygen during the early years of its growth. In fact, it's the younger trees that give off the greatest amount of oxygen, while the older ones, the ones we use, tend to hit an equilibrium. I have been in structures in Germany, in Italy, that have been in continuous habitation for 700 or 800 years. Anytime you have a product that services man for that length of time, you have to consider it a very green substance. Thank you.